Next graph. This graph gives you non-ideal mixture with positive deviation. The first question is how to identify positive deviation. First, you should know this green lines. These lines give you partial vapor pressure starting from 0 for this and going up to x11. So, they will give you partial vapor pressure of an ideal condition, one component. This green line, which I am highlighting as a red, is partial vapor pressure of component 2. How you came to know it's component 2? Right here, its vapors were 0. Here, vapors were maximum. So, that was for ideal condition P2. And this green line was vapor pressure of a mixture in ideal condition. But we are not learning ideal, we are learning non-ideal. And what you are able to realize, vapor pressure of the mixture of a solution is above. That means vapor pressure is more. When vapor pressure is more, we call it as positive deviation. You know, more means better, positive deviation. If mixture is positive, even the vapor pressure of each component will be more than expected. That means we are trying to say if you take component 1 and component 2, they make up non-ideal mixture. Now this non-ideal mixture of two components have repulsive forces. Because they have repulsive forces, molecules of liquid 1 and molecules of liquid 2 don't want to be together. If they don't want to be together, we have two options. Either they would like to remain in liquid state or they would like to go into vapor state. So the mixture can either go into liquid state or they will go into vapor state. But they have repulsive forces, so the molecules want to go away. If molecule wants to go away, they would not like to remain in liquid state. Instead, they will like to remain in vapor state. That means their vapor pressure will be more. If their vapor pressure is more, that means its vapor pressure is more than expected of ideal condition. Again, this also tells you intermolecular forces are weak. Forming vapors is easy. If forming vapors is easy, what about boiling? Boiling is also easy. That means they have low boiling point. So, non-ideal mixture with positive deviation have repulsive forces. One conclusion. That means intermolecular forces are weak, or you can call them repulsive. They form vapors easily. That means their vapor pressure is more. And they will boil easily. That means they will have low boiling point. Then such mixture can eventually form azeotropic mixture with minimum boiling point. So the same graph will be there for azeotropic mixture with minimum boiling point. That was the graph for non-ideal mixture with positive deviation. The next graph that you are able to see is non-ideal mixture with negative deviations. What you are able to see, the vapor pressure is less. If vapor pressure is less, first thing, they make up a non-ideal mixture. If they were making up an ideal mixture, then the line should have been straight line, which is not the case. So they make up a non-ideal mixture and they have attractive forces. If they have attractive forces, then molecules like to remain close to each other. That means molecules will like to remain in liquid state rather than vapor state. Because they like to remain in vapor state more and liquid state more and vapor state less, they produce less vapors. If they produce less vapors, their vapor pressure will be less than ideal vapor pressure. Vapor pressure less, that means intermolecular forces are strong. Vapors are formed with difficulty. If vapors are formed with difficulty, it is difficult to boil such a mixture, or it will require more amount of heat to boil them. If they require more amount of heat to boil them, they will have more boiling point. Then such a mixture will eventually give you azeotropic mixture with maximum boiling point. Any example of a azeotropic mixture with minimum boiling point? Yes. As per NCERT, ethanol plus water. Another example you want to give, ethanol plus acetone. Any example of azeotropic mixture with maximum boiling point? Yes, example is available. What is that example? Acetone plus chloroform. Another example, phenol plus aniline. Another example, nitric acid plus water. All these components have maximum boiling point because they have stronger forces in their resultant conditions. So these were the two graphs for non-ideal mixture. One with positive deviation means graph on the upper side, more vapors, and negative deviation where the graph is on the lower side. Lower side graph. If your marks are on the lower side, you say negative. If your marks are on the higher side, you say your marks are positive. So that was discussion of graphs of vapor pressure of non-ideal mixture.